As you can see, I have a website, I have a Twitter. Tonight we're going to talk about AR, VR, that tech landscape, and how regular web and app developers can start getting into that. Is this a good volume? Can you hear me from within this cave situation? Is this good? Okay. Let's get started. A little bit about my background. Lifelong writer and tech nerd. Where are my notes? One time, sorry. I have some speaker notes that are kind of important, so 1 second. They're not appearing. That's not great. Well, I'll roll without them. Hopefully I say everything I intended to say. Okay, so.
Did you split the screen?
It is split. The thing's even coming up, but the notes that I wrote aren't there for some reason. But we'll do it this way. So yeah, lifelong writer, tech nerd. I have a journalism degree. I did some marketing for a few years. I still write for tech publications like Upload, VR, and VR Focus. I pivoted to web and app development about 5 years ago because I just saw that's like where my skills lay, and that's where the demand was in the market. So, and in the last 3 years, I've been focused on like virtual reality and augmented reality technology. Got nominated for a Webby Award for one of my AR projects this year, featured at Augmented World Expo, featured at St. Louis Science Center. So it's been a really cool year. Tech's moving fast. Super excited about it. So let's talk about what we'll discuss tonight, which is basically the state of this tech and the industry via use cases, best practices, what the hardware now is like versus what it just was, and perhaps where it's going. And I'll also talk about, case studies of awesome VR and AR. We're going to dive into some brief intro of Unity 3D and A-Frame, just to kind of get a look at what that looks like, and how to kind of code in these heavy 3D interfaces, and specifically how web devs can kind of do that. And at the end, we'll just wrap up with Q&A and demos probably, so that'll be fun. So what is VR, AR, sometimes called XR? Overall, we're going to call it spatial computing, and that is just like any software where the UX involves 3D real-world space. So the kind of trope there is VR is a totally digital environment, and VR can take you anywhere. It can put you in any alien environment and take you anywhere on Earth. AR is about overlaying 3D content in your physical space. So VR can take you anywhere. AR can bring anything to you is kind of the trope about that. So yeah, that's augmented reality, virtual reality. The X is kind of a variable, but there's a lot of marketing and jargon going on right now that probably won't hold up in the long term. I think of it as spatial computing, 3D tech, AR, VR. If we're fairly comfortable with those terms, we can probably go forward. Can I just click it? So what can you do with this technology? Basically, we're finding out now. This is a pretty famous piece of footage from early history of film. It's the arrival of a train in La Ciotat. The Lumiere brothers, and two of the first ever, videographers, cinematographers. They say when people saw this in the theater, they ran out the doors because they were terrified they were about to be crushed by a train that was coming straight at them. And that's exactly where VR is right now. There's so little standardization between hardware and software, different manufacturers and devices, different ways to deploy. Just like kind of in the early days of film. You couldn't ask Lumiere, one of the Lumiere brothers, what all the possible use cases of film would be in that day. They didn't know. We don't know today what all the possibilities of AR and VR are. So it's kind of uncharted territory, and I think that's what attracted me to it in the first place. Yeah. That's all I want to say there. So here's some of the more, society has produced some fiction that has already imagined these worlds. And so these ideas aren't necessarily new. We've been kind of brainstorming for a long time. So this idea of the metaverse is really common in VR, which is one shared, infinite, connected virtual space. This idea of infinite personalization of yourself, where you can look like anyone. That's a common theme running through all this stuff. So what's new is really the ability to actually make this stuff happen, and that's pretty exciting. So I'm going to start with AR. We'll probably focus on that a little less overall. Overall, the AR ecosystem is a little farther behind. That's why I'm labeling it the AR 1.0 release candidate. It's not quite there on either the mobile side, which is what you see over here, or the AR HMD head-mounted display, AR glasses, as you might call it in shorthand. AR glasses, still extremely expensive, still a very small field of view when you actually look through it. Both of those are around $3,000 and almost useless on a day-to-day basis. It's, totally impractical at this time for consumers. That said, there's probably a lot of like industrial and medical applications that are being explored right now that are really interesting. Kind of the same for the mobile AR side. It's been gimmicky. There's not a runaway hit at this point, but let's talk about like why that might be. So this is kind of the style of GIF you see when people are talking about AR. It looks amazing, right? But these projections just don't live up to the reality of the current gen hardware. This is where we want to go, where there's a lot of like surgical trainings, actual surgical assistance, some manufacturing, some construction tasks are being done. And I think that is really how the tech is going to come along. It's going to come into the workplace first, where people aren't worried about what they look like. They're not worried about privacy concerns. It's work, your time belongs to your employer at that point. So the use cases in these big industries are going to drive the technology to get better and better. Then it's going to leak into the consumer market is kind of what I see happening. One thing I would kind of call out is this is a really interesting, it's actually an open source hardware design released by Leap Motion. Leap Motion's been around for a long time. They do hand tracking via infrared sensors. So they released this headset design. It costs, if you have the wherewithal to put it together and program it, it only costs about $300 in hardware. Far outpaces the $3,000 HoloLens and Magic Leaps of the world. And their designers are great too. You can see this kind of like virtual office, virtual HUD images over here. And again, I think that's indicative of the fact that this is going to evolve in the workplace before the form factor really becomes comfortable and the privacy norms become comfortable for consumers. So the other side of the AR thing is mobile AR. And these are probably the kind of use cases you've seen so far. We're talking about like being able to place a piece of furniture, IKEA furniture in your living room. We're talking about some basic like ruler apps, face filters, the great Snapchat stuff that the young people love so much. And then this is actually my business card on the right. So there's some image tracking inherent to the current mobile AR SDKs. So it's recognizing my business card out there, and it's projecting this kind of Commodore 64. Tough to read in this resolution, but my little elevator pitch is being typed out on this Commodore 64, which is what I learned to type on at Coldwater Elementary in North County. So, any North County people? Hey. So yeah, this tech has been pretty limited so far. It can see planes. Lately, it can see horizontal as well as vertical planes. There's only so much you can do with that because, one, it's not persistent. You can't save a scan of a room and later come back in that room with the current AR SDK on mobile. That is changing, though, and I'll show you. It's not really happening on the native platforms yet, but there's this startup I've been following for a while called 60AI. they're running complex geometry scans on a single cell phone camera in real time and allowing for like realistic physics in those environments. So you can kind of see the raw mesh in there. You can see the visualization of that balls on the table over there. So one thing, my current like passion project is using this tech. If I can find my mouse again. Okay, cool. Using this tech, you can see over here, like this is a visualization of the real-time meshing. So again, this is just a single cell phone camera, like determining complex paths, determining complex geometry of that table, of the couch, determining a walkable area for my AI character. And so that allows stuff like this, which is missing from a lot of current AR, where my application knows there's a wall there. It knows my little virtual pet is on the other side. And it knows it's supposed to hide it when I'm behind the wall, right? That sounds simple to the human brain, but AR just hasn't been able to do that yet. So I've done some cool voice commands, developing this concept. It's called Party Pets with the St. Louis Developers Co-op. That's their logo down there. Some really passionate and cool people in that group are helping me out with this now. This is like the prototype. We've got original art coming along. It's going to be super cool. I'm really excited about that one. So what's next? Oh yeah. So I'll segue into VR with a story that intersects. I'll segue into VR with a story that kind of intersects both. There's a Columbia, Missouri-based startup called StoryUp. And they're experimenting basically with like the therapeutic qualities or the potential stress reduction qualities of AR and VR tech. So they're kind of using these EEG sensors combined with XR technology to see if they can promote stress relief in high-stress industries like first responders, like deployed military and stuff, putting them in environments that are inherently more secure and calming than what they might actually be exposed to on the day-to-day. So there's this WXR venture fund, funds a bunch of companies out of Silicon Valley. They had a virtual reality social event. It was a pitch contest in VR. The founder of StoryUp was at this pitch contest, PowerPoint presentation and all, and just kind of standing there in real time, like standing and delivering her pitch. There was a poolside after party in another room that we went to in VR. I introduced myself, and a few months later, we were working together and developing both VR and AR apps. And I'll talk about that.
So that kind of reminds me of Second Life.
Mm-hmm.
I don't even know if Second Life is anymore.
Second Life, if you're inhabiting the world, and the three, we'll kind of get to the difference between a 3D camera in a traditional 3D game and the VR camera, which is inherently mounted to the face. So this is the app we worked on. Basically, you hatch butterflies with positive thoughts in a guided meditation experience. So you're having a narrator kind of delivering this monologue of like telling you to have peaceful thoughts and focus your breathing, and the EEG detection works, and if your stress levels spike, it kind of responds with some encouragement or something like that. So yeah, you go from hatching a butterfly, and then they're pretty much everywhere. And this was actually we showed it at Augmented World Expo last year. It was nominated for Best Use of AR at the Webbies, which I'm really proud of. I think that's super cool. And it might go on Shark Tank soon, apparently. Well, we'll see. That would be neat too. Where are we? So yeah, let's move on to VR. And where we are in VR is kind of like VR generation 1.5. Oculus Rift was really the first mainstream consumer one. That was out in 2016. And I'm eagerly anticipating the release of kind of the next class. So we can talk about some of the key differences in approaches, and all these different UX battles that are still being fought between these different companies. Oculus's latest two headsets on the far left there, they no longer use external sensors. So all the tracking is built into the headset. And actually, I have one right here. This came out Tuesday, yesterday. It's amazing. So this is a completely standalone headset called the Oculus Quest. That means there's no PC required, there's no external sensors required, and you have full room scale, freedom of motion, two controllers tracked in 6 degrees of freedom, which is kind of the VR parlance for full freedom of motion. There's pros and cons to the external tracker, internal tracking approach at this point. If I put my controller behind my back, this can no longer see it. Whereas a triangle of external trackers can see you from every angle, basically. So there's times where you lose a little bit of tracking with this stuff, but it's just so much more convenient that trade-off is still kind of being explored. Hopefully the tracking improves on this over time. It's already really good for most applications. So that's versus this Valve HMD that just came out, and the HP just came out. Higher resolution than either of those two, but directly plugged into a PC, so it can push out like massive 3D graphics card processing that a mobile processor running on 4 watts of power just isn't capable of. You hear a lot about different controller styles. None of these inputs are standardized. They all have slightly different features. They all behave in slightly different ways, which is super annoying if you're trying to make a game that you want to be experienced by as many people as possible. So we'll talk about kind of the push for standardization in this market. Wild West, yeah. Moving towards standardization, but yeah, again, just that cinema of attractions era, anything goes, let's throw it all at the wall and see what sticks attitude, basically.
Do you think there's like a best in class for the standardizer around?
This just went out for pre-order 3 weeks ago and sold. I was really looking forward to it. It's the most expensive. Looks like it's going to be the best. It's the Valve Index. But the pre-order sold out till like September in the first day, and I was like, shit, I don't want to wait that long, so I haven't ordered that.
How much does that cost?
All told, controllers, external sensors, HMD, $1,000, and that's before you get to the beefy PC you need to actually run it, So, yeah, it's still expensive. That's one of the things I'm most excited about. This is it's $400. So the price point's really coming down to like console levels. And now that it's more portable, my hope is that people will kind of be able to experience it more, and the tech will kind of get some renewed investment at that point. So here's some of the coolest VR apps in the world. You might be familiar with Beat Saber, which turns you into this funky Jedi where you're dancing with lightsabers and slashing rhythm boxes in half. Insanely fun. There's this whole class of 3D modeling and creative tools that are coming out where, like, right now 3D modeling is insanely difficult. Every software suite has this insane labyrinth of keyboard shortcuts and mouse clicks you're supposed to navigate to be able to model well. I'm telling you, doing it in 3D, doing it, molding and sculpting in 3D space right in front of you, where you can infinitely scale it up and down, it's incredible, and it's so much more intuitive than you might expect. Like, I'm not artistic, and we'll come to some stuff I modeled in a moment. Over here you have Google Earth VR, where you can literally just soar around the Earth like Superman in complete 3D. That's probably the one that makes people cry the most, because they go to their hometown or something that they haven't been to in 30, and it's like, oh. There's a lot of like trainings and sim stuff going on, whether that's like training for heavy machinery, training for medical stuff. Walmart bought like 30,000 of this thing's Predator to use in its training sessions. I think the idea there is it just totally, so there's no distractions, so you're focused on whatever is in this thing when you're using it. And I think that's where probably the value add is for training in general. Oh, another slide. Okay. Vader Immortal just came out on this thing. Star Wars. You become Darth Vader's apprentice, guys. It's awesome. And I'm telling you, when he first walks up to you, you're supposed to be strapped down. You can't take any action, and it's intimidating. It's just like, well, he's this big, you know. It's like just great experience. Over here we got Robo Recall, one of Oculus' main launch titles. Still one of the best looking, most fun games. You can kind of see the teleport mechanic happening in that. That's pretty common locomotion tactic in VR these days. Is like, instead of like having a smooth locomotion video game style where you're just steadily moving forward when you press the joystick down, this kind of teleport thing helps some people if you're like sensitive to motion sickness. That's a game called Boneworks coming out on the Index. It's set in the Half-Life universe, which people are excited about. They think there's a Half-Life sequel, which is a famous, very influential video game from early 2000s. This is Rec Room, which is probably the closest thing to like metaverse, shared social space with almost infinite variety of activities. They have great like sponsored content, like there's a laser tag arena, there's paintball maps, and it's all in, you know, it's all social, it's all in real time, multiplayer. Playing paintball in this thing, being able to just like duck behind a boulder and like pop, pop. So fun, guys. It's just it's a blast. It's like totally different take on any kind of shooter. So those are some of the best publicly available stuff. So popping back to the story up thing, this is just a quick clip of the VR kind of similar concept we were exploring. Like there's this is a famous tree in Columbia, Missouri, actually, and it starts off kind of desiccated, and your positive thoughts make flowers grow and makes the graffiti disappear and makes, you know, kind of the tree bloom again. So again, kind of exploring that stress reduction and guided meditation idea. I got a chance to work with some WashU researchers, actually, who were studying. They're geriatric scientists, so they're gerontologists, yes, studying the process of aging. So they're kind of studying like how aging people use landmarks and navigate new spaces when they're unfamiliar. So we have just a whole bunch of experimental conditions. People sit down in a chair, and it's almost like driving an electric wheelchair for them when they have the headset on, because they're sat down. They're able to look around, but they don't have to get up or walk or anything. And they're just kind of driving a scooter while looking around and solving these mazes. Huge like data harvesting, analytics portion of it too. It was a really interesting project. The study is currently being conducted still. It's like a couple years long, I think. So this is the first VR project I ever made. And going back to the VR modeling theme, so that's my BB-8 that I made in Google Blocks, which is like a low poly modeling thing. I decided to make him because he's only like 10 different shapes, not too tough to get right. The hard thing was actually like bisecting the very simple geometry of the low poly sphere to like do the designs I wanted to do. You can kind of see when he rolls up. I got a lot of like wires and stuff all over him. There's actually a cool, we'll talk about lighting in Unity maybe, but I actually have a spotlight floating right above his eye wherever he goes, so there's this little red glint like it's in the movie. It's kind of neat. So this explored like voice commands in VR combined with like room scale tracking, because what I'm doing is pointing and saying go, and a little ray fires out of my finger, hits the ground. BB-8 knows he's supposed to go there because of my command and because of the ray cast. So that X-Wing in the background, I did not do, if you were wondering. There's actually a public repository for this Google Blocks thing. People can just publish all the models they work on. It's really cool. So I wrote a piece on this whole process, like a deep dive into the whole Unity modeling, VR content future. It was really well received. I got super lucky. The vice president of Unity Labs, which is their advanced R&D department, flew me out to San Francisco to spend the day with his team. There I am, having a great time. And it was a weird meeting because there was a bunch of misconceptions. He thought I lived in San Francisco, and he wanted me to help him write a book. But it just wasn't going to work out because I live in Missouri, and yeah, wasn't going to happen. But it's still a really cool trip, and I did spend the day with his team. And their kind of discussion, the importance they placed on AI and machine learning for all these tools, really guided my learning after that. This was like late 2017, I think. Yeah, so I really wanted to start diving into ML, AI stuff at that point. I wanted to do it still in a VR context. So the next project kind of involved this MNIST, which is like considered the hello world of machine learning. I'll start with this. Basically, it's 50,000 28 by 28 images of handwritten digits. You can train a convolutional neural net to read all that data and basically come up with a model for what a 1 looks like, what a 0 looks like, and so on. And it can be visualized kind of in this heat map style. Like a 0 is very seldom going to have anything in the middle. It's quite likely going to have a bunch of strong pixels around there, and so on. So I thought, well, that's cool. I understand what's happening there for the most part. What else can I do with this same kind of process? So that's when I found this Google Quick Draw library. So this is another huge database of image data. Stuff like a diamond, a coffee mug, thousands of images of these each, user-submitted stuff that you can train a machine learning model to identify, basically. So what could I do with this? I can draw basic glyphs now instead of just numbers. That's pretty cool. So this is kind of where that headed eventually. Rune Mage was kind of my code name for this. So you're basically drawing glyphs in the air, and in response to what you draw, the machine learning model recognizes it, casts a specific spell. This is also using the whole leap motion hand tracking thing, so I have complete, like, access to my hands inside this VR experience. It's really accurate and really cool. You can see my little Python server processing the request down there when it's kind of a draw, cast. The server receives it, makes the prediction, and we cast a spell so we can click through. A couple more of these. Cast ice wall, and this one makes it snow if you draw a little lightning bolt. Super interesting project. Learned a lot about ML, a lot about VR. So at this point, it's like, okay, this stuff's all pretty cool. How do you do it? So again, we're going kind of coming back to this fragmented landscape thing. There's a lot of different ways, a lot of different approaches. Here's kind of my basic map of what's going on. And I see it as two approaches on the VR side right now, and I guess only one approach for AR, which is you can use a game engine like Unity or 3D, which we've seen some of the products of, to publish to all these different platforms downstream. So you can export your Unity project to Android, to iOS. You can deploy it straight to Oculus or any of the other headsets, or you can use Steam's SDK and port the app to there, and then they'll take care of porting it to the other headsets. You can use WebVR, WebXR stuff to publish VR, AR content to the browser, and then the browser is actually what's responsible for pushing out to their end devices. That's still really early. There's W3C working groups and community groups working on that now, but we'll talk about that. Excuse me. Next slide. So OpenXR is a industry standard coming along with all hardware and software manufacturers. Seems like everybody's on board, actually. It's kind of cool. So on the left here, you kind of see the current framework that I just laid out. Unity is responsible for maintaining its own port to all of these headsets. Unreal is responsible for maintaining its own export. Under the OpenXR model, all of these engine platforms will use the same kind of open source spec to publish to all the headset platforms, to publish to all their different devices. And again, there's some, on the WebXR side, there's some working groups and community groups. And let me skip back, what was I saying there? Oh yeah, there's a GitHub project for the whole immersive WebXR spec, which is different from the WebVR spec. I guess the WebVR spec's a little farther ahead, but they're going to merge at some point because it's largely similar principles. So this is basically what Unity looks like. It's a very GUI heavy, graphic interface heavy programming platform, basically. You can kind of think of it like Photoshop, but it's 3D and there's code. There's a million options, a million menus, some of which you may never use. But it gives you so much amazing functionality for free. It takes care of 3D rendering. It takes care of AI and navigation. It can take care of in-app purchases, for instance. All these different things. They have 1,000 engineers employed around the world to make your game and experience development process as smooth as possible. And there's a lot of jokes in the industry about Unity's reliability, but I've always found it to be pretty awesome. They push 3 or 4 updates to it a year, which always have major new functionality. I'm a big fan. What's next? So yeah, publishes to all the different platforms. Has a physics engine, has multiplayer capabilities. It's free-ish, it starts free. Unless your organization makes more than $100,000 on Unity software, it's totally free, which is great. It's got an asset store, so even if you're not a modeler, if you're a web developer and you don't have a ton of asset making experience, there's an integrated asset store right in your programming environment where you keyword search anything you could want. It makes it super quick. And there's tons of awesome learning experiences. I always like to share that my journey to VR was Unity tutorial number 1, where you make a ball roll inside a box. I did a 2D space shooter after that, like a Galaga kind of thing. And I did a little 3D tank game over the course of like 3 weekends. And I was like, okay, I can do VR now. I get it. It's like the process of building a normal game, a normal 3D game in Unity is not at all very different from the process of making an AR game, or AR/VR game, I guess. So I would, in addition to the Unity, there's also kind of a framework within Unity called VRTK, which is the VR toolkit. It's open source, allows you to publish to a bunch of different headsets in a way that Unity can't quite do yet. And there's all these reusable VR components like player locomotion mechanics like teleport or snap to zone, which is a thing where, say you're playing a game, you have a holster here where you put your sword. If you are holding the sword and you just kind of drop it within a certain zone, it's going to snap back in your inventory or something. That's what snap to means. There's also physics prefabs for how objects should behave, because Unity has a full physics engine, so you can define, you put a sphere in your 3D environment, you can define the mass of that sphere, and it'll fall according to gravity at a very at the correct speed, which is really interesting. So VRTK was open source, now it's Unity backed, which is cool because it looked like it was going away for a while. There's the link down there. Keep losing my mouse. So on the other side of that is the WebXR side, WebVR side. It's still coming along. It's not as developed as Unity. Unity is a game engine that existed years and years before AR/VR. So they just have so many more resources to plow in. This is all an open source effort. And there's some amazing stuff you can do with it. But really, I'm pretty sure there's no physics as yet, or all the physics libraries are like very experimental. It's based on that WebXR spec, which is still they're in the process of making. It's also based on Three.js, which I know there have been some meetups about. So if you're familiar with Three.js, you can definitely do A-frame. It's pretty much the same thing, again, with like this VR camera that we keep talking about. I'm a big Twitter person. If you're interested in this industry, these are like 6 people that, if you follow them, you will know just as much about this stuff as me probably within a few weeks. Timothy West was who invited me to San Francisco. Super cool. Super smart designer, worked for Apple for a long time. Kent Bai's podcast is amazing. Hundreds of episodes with all indie and professional XR creators. Ian Hamilton's my editor at Upload, great guy, very knowledgeable. Amazon Sumerian is kind of an interesting, like, there's some approaches to AR, VR that want to be very consumer facing and very friendly. Like, so setting up a Snapchat lens or something like that, or a Facebook filter. They have tools for that are entirely graphically based that you don't really need coding for. So that's kind of another path into this if you're kind of on a marketing level with it. Amazon Sumerian is one of those efforts. Nell Wallachek is a really smart designer. John Carmack created Doom and is now Oculus CTO. Trevor Flowers is in that immersive web group. Very good follows all. So I'm going to hop out of the slides now. Too early for that one. This is that immersive web spec. Actually, let's do the Unity thing first. Unity's pretty immediately. So this is kind of the internals of Unity. This is what the editor, it's very customizable, but this is what the editor looks like fairly by default. So this is the village I used, the village assets from the asset store that I used in my Mage game. I'm just kind of click around on some stuff and show you how it works. Again, like any 3D engine, you kind of have to know the keyboard shortcuts to make your way around this thing. It can be a little daunting. And also, Macs are not the right platform to do anything 3D. PC is generally way better. So all of these things are game objects. And one thing that's extremely similar about developing in Unity for web and app developers is it's very hierarchy based. It's very node and almost like a DOM you can think of. So we have a scene, which is like our HTML tag, right? And then we have all these kind of, it's called an entity component system, or it's their version of an entity component system. So for each of these game objects, which is the base class of anything in Unity, you can attach scripts, you can attach physics stuff. It's all scripts, but you can very easily set up physics and set up kind of like your AI navigation mesh and stuff like that. So this is the lighting, so there we go. So you have, for any given game object, it's always going to have a transform, whether that's useful or not. And so this kind of controls your position of the game object. You can move it up and down and left and right and back and forth. And I mean, the only difference in programming this stuff versus like programming on a canvas in HTML is it's vector 3 instead of X and Y, right? So it's X, Y, Z. And there's rotation values as well. But it's not insanely complicated versus yeah, just programming for a canvas. You can scale stuff up. So if I want this to suddenly be 3 times the size, I just change the XY, the scale values on X, Y, and Z to all be 3. So now it's a huge tree. And also, yeah, there's just different rotation values. Spin it around. And this is how you basically compose a 3D scene within Unity. So whether you're making a normal 3D game, whether you're making a VR game, this is the process. You add game objects which have mesh renderers. If I click off the mesh renderer, tree goes away. The mesh renderer is kind of like what's telling it how this should look. And using this mesh, basically, which is one of my assets down here. So yeah, it's divided. I should have said this earlier. It's divided into the hierarchy, which is your active scene DOM, you can think of it as. And this is kind of your whole project file structure, which this is a VRTK project. I imported the assets I wanted. If I had my if I had my PC here, all I would have to do is put it on and hit that play button, and I'm instantly in this world, and I can develop and make changes and iterate in real time, standing in front of my keyboard. So the cool thing about developing on a PC is you can iterate very rapidly. You can instantly jump in and test your experiences. Versus for this thing, since it's mobile, since it's Android-based, I have to build and export. I can't do the kind of real-time hop-in, which is a little unfortunate. Hopefully they push the tools along on that.
So what do you use at home for development?
I have a Rift. That was my original headset I got. I don't use it as much as I used to. There hasn't been a lot of big new content recently. But I still get a kick out of just bringing people over and showing it off. So that's why I'm excited about this thing, because I can just, take it anywhere, show my family or something like that, right?
So to get to this point, you essentially installed Unity, opened it up, went to the asset store, grabbed this asset.
Import. Yeah. So you could, and this was basically the demo scene. I can zoom all the way out. It's actually pretty huge. This was the demo scene that came with it. It also includes all these little different assets individually. So if I wanted to mold my own village piece by piece, I can also do that. I'm sure they do. Am I on the internet? Yeah, I'll show you real quick. It's pretty cool. So this is the asset store, my Polygon pack. Let's see. Game of might be kind of a protected, no results. It's not a very popular show, so probably no one's heard. Do I have a game? So yeah, this is your scene view where you're constructing and building the world, and you can move around in it as you please. This is your game view, which actually shows you what your main game camera is seeing. So in a 3D game, you might have this mounted to your main character's shoulder, so you're seeing over the back of them. And whenever they turn, the camera just kind of pans around behind them. That's common, right? Again, the major difference in VR is the camera is just basically attached to your HMD, which is tracked in real time. So at about 60 to 90 frames a second, depending on your headset and 3D card, your position is being read, and the next frame is being rendered just before you see it, basically. And you're only really getting small, chopped up pieces. But because the tracking is so good, it just flows together. You don't really see the black unless there's a lag problem. So yeah, let's dive in here. So there's my imported scene. If we dig into the VRTK thing, you'll find this prefab, and Unity runs on prefabs, basically. They're like pre-composed game objects that you can just instantiate as you please. As needed, they can be bad guys, they can be your main character, they can be a piece of UI. It's any pre-made game object that you may want to just like save and use for later or use multiple times. So in our case, what we want to do is just drop in a Unity XR camera rig. That's not the scene. I need the scene. So if I was getting ready to make this normal 3D scene a VR game, what I would start with would be to drop in a VR camera rig. And as soon as it's in there, I want to zoom in. Where is it? So you can barely see it, and this is positioned like weirdly high in the air. But there's a camera frustum there. So you can see exactly what the outline of the player's vision would look like from that position. Now again, once the game starts, this is hooked to somebody's face, so the camera for us is going to be wherever they're looking. But just doing that, is enough to be able to take a Rift and hit play and hop in this world. And all of a sudden I have, a prefab that lets me navigate around with my joystick and look wherever I want, kind of explore. And from there, it's up to me. What do I want? Do I want to make it an open world MMO, like World of Warcraft in VR? Do I want it to be an adventure game or a puzzle game? The programming of the actual experience is up to you. So let's jump into one of these scripts. So on these games, just to reinforce the point, if we look at this Unity XR camera rig prefab, it has scripts on it. So this is a Unity XR configurator script. So I don't need to know what this does, but if I want to, I can pop it open, say I'm going to preview in here, or open it up in my code editor of choice. This is C# code. Unity is generally in C#. If you're an Angular person, it's very TypeScript-like. I understand it's Swift-like too. I'm not very experienced in that though. So it's strongly typed, very object-oriented based. So if you have experience in that, you'll probably feel right at home, honestly. Let me move this file over. I don't know what this does, but let's take a look real quick. Can I read it? How in Visual Studio Community to do this? Looks like Command plus R. So yeah, the Unity and C# operate on lifecycle hooks. So there's an onCreate that you'd see in a lot of other object-oriented spaces. There's an update that runs once every frame, which can be interesting because every machine will render the same frame in a different amount of time, depending on the hardware. So in the update, you actually have to be very conscious of how many milliseconds has passed since the last update. It's always going to be different. So you kind of have to watch it and add the time incrementally. Even on the same machine, different frames will take different times. And this is kind of what that's looking at, actually. Tracking the time. This fixed delta time and time scale divided by the refresh rate of the device. So again, this is all stuff that if you had to figure it out from Jump Street, you might struggle. It's a lot of complicated 3D math. There's some computer vision magic going on involving all the tracking. But again, the glory of Unity, the glory of VRTK is it just kind of prefabs that away and allows you to be creative and still adjust the code as you need. So let's find maybe a more useful, not just a configuration file.
So is all that code in one class?
That is one. No, it's kind of, it's going to be like any coding project where there's a file folder structure according to whatever the creator set it up.
The code that you just showed?
Yeah. So this was part of the VRTK project that I basically used Git to bring into my Unity project. So it has its own folder structure that I don't have. I can rearrange it if I want, but there's probably not a lot of benefit for me to do that.
So do you have to bring in something like a Git package to add that to
Git. So there's a GitHub repo for VRTK. You start a Unity project, change directories into the Unity project, and clone the VRTK GitHub package. And Unity will detect that, import everything properly, and you should be up and running to have let's find something else. Teleporters, that sounds interesting. Teleporter.instance. That's a prefab, actually. Scripts. Teleporter, facade, teleporter. setting up enums, setting up the class. Everything in Unity is a mono behavior. If it's a game object, it's a mono behavior. That's what it's called in the script. And of course, this was a European company, so they have a lot of Britishisms in their class spelling names. It's just what they call a game object. Allows this class to be instantiated in the 3D world, pretty much. I don't know why it's called mono behavior. VTRK is the open source toolkit that allows you to easily build VR apps with Unity. I've actually never built an app. It came out after I did all the stuff I've showed. So I've never actually used it to do a project, but if I had to start a new project, it's what I would use at this point. And that's why I framed this talk in the context of 2019, because it's very, the approaches you might use next year, it might be an open XR SDK that's out at that point. So you don't need VRTK because it's all open XR, the spec I was talking about earlier. So these are kind of little, you can write scripts that modify the Unity editor, the graphic Unity editor that we were just playing around in. So this is like adding a little tooltip to a piece of the Unity editor. Things like that. I probably should have found a better script to demo. Well, again, a lot of configuration stuff going on. If I really wanted to dive into all these different classes, follow the trail, figure out exactly how all of this works, I could. Or I could just start, diving into my 3D world and building out my story and my characters, which is I'm a web and app developer. I'm game developer adjacent. So I'm a writer in the past as well. So I like to be creative, and that's kind of where I attack this from. There's other people that know a tremendous amount more about the actual 3D rendering, about the physics and stuff. I just think being able to create your own world is a really exciting thing. So let's contrast this with A-frame. So A-frame.io. What time am I at? 8:15. Cool. A-frame.io is basically the repository for a bunch of demo projects and the A-frame source code that is again based on Three.js. So let's just get started because the documentation, well, let's look at some examples. Because one thing that is cool about this is it's very backwards compatible. So if you don't have a VR headset, this just becomes like a third-person game you can click around in. Maybe our connection's a little slow here. If it loads, there we go. Yeah, so this is just a 3D world defined in HTML and JavaScript. And again, I'm viewing it on a 2D monitor and just clicking around it. I think I have WASD keys. Yeah, move around like this, like it's a 3D game. No jump button, unfortunately. But yeah, this is defined in HTML. So what else? I don't want to click through another because it's a little slow, but let's see, get started. So blow this up to. This is what an A-frame scene looks like at its core. So you start with HTML. You just, as if it were AngularJS or something. You're just importing it as a script, and all of a sudden you have access to all these A-frame custom web components. So you start within the body by defining a scene. These are different primitives, they're called. So it knows what a cube looks like, right? And you can define its position just like this is exactly what a Unity transform is. You're defining its position and you're defining its rotation. And I guess I should say this is all based on an origin point. So for any 3D scene, there's an arbitrary 0, 0, 0 origin point. all this stuff is relative to that. That's called global space, or there can also be like a local space, which is, so I have a cube up here, it's got a child object. If I was to update the child object's transform, it would be relative to the cube, relative to the parent. So there's local space and global space in this stuff. The rotation is just, no, that would be like a physics force applied to it. The rotation is just what direction is it facing? Am I starting this way? Am I starting this way? You know, so that's the x. Or if it was y and I could flip my body upside down, you know, that kind of rotation. Yeah, so I mean, how simple can you get? Like defining a 3D scene in terms of HTML. They have a really great tutorial school. A bunch of cool demo projects. Oh yeah, and so you would just deploy this on a web server, right? You would set up the project file, be able to access it from some URL. This A-Frame actually is way ahead at doing really easy mobile, really easy VR multiplayer, because you can just open a service worker to your server, and all of a sudden multiple people can inhabit the same space. You're really only sending like position and rotation data back, so it's pretty near, you know, it's very real time. It's really cool. So again, A-Frame will also have like demo scenes and example projects that you can click through, see how stuff works if you're really curious, or just start playing around yourself. Similar to Unity, it's the entity component, so you define your top-level object, and then you add components to it, whether that's a physics component, whether that's a certain mesh that you want rendered on top of it, things like that.
So what websites would I go to practice that, like to start off as a beginner?
So aframe.io is where I'd start, and they have this A-Frame school. It's going to allow you to, like, it's going to be a code editor within your browser. Let me see if I don't know if you have to log in or not, and I don't have an account. But it's going to provide a code editor in your browser that you can make changes to, see the changes in real time. Again, even if you don't have a headset yet, you can mess around in A-Frame and kind of build your own little worlds. And the UI is confusing too. I know there's something I'm supposed to do. It's like a hidden thing. Well, maybe it's just not loading again because the network. That's probably it. Yeah, so check out A-Frame School if you want to learn more about the HTML, JavaScript, WebVR side of it. If you're more interested, if you played with it and you have an app idea you're really interested in and you want to pursue, I guess I would suggest moving on from WebXR. But it's a trade-off. As this advances, it's going to be so much easier to deploy these experiences via the web. It's kind of just like the progressive web app thing. It's so much easier to deploy an app via a URL than to put it on an app store, have somebody have to download and install it. It's just like, when the metaverse comes, it's going to be more like this. It's just not there quite yet. Right now, Unity is the better choice to make like the more fully featured stuff. I just kind of wanted to brush over this and point y'all in the right direction. I don't expect to convey a ton of mastery tonight. But those are the resources as I see it. That's kind of the landscape as I see it right now. It's an exciting place, lots of room to kind of really be an innovator. Like I'm never going to improve on the state of app development because I'm just not that deep into that pipeline. But I can contribute in real ways to the AR/VR ecosystem because it's small and because it's so new and there's so many use cases that need exploring now. So yeah, that's kind of wrapping up my thing. I think we can do demos of this. If people want to try, we can ask questions, continue discussing. I was hoping I was talking earlier, the main out of this thing, you're supposed to be able to stream it to a Chromecast and just like watch what the other person's seeing. That feature's in beta though. It's not working now, unfortunately. So we won't be able to spectate what people are seeing. But yeah, and if anybody wants to come up and try their hand at this thing, it's really cool. A bunch of good games on there. Otherwise, we can just kind of keep talk or take off. I think I'm wrapped up.
Thanks. So, the A-frame clearly, has potential to get you off the ground quickly, but this all looks rather computationally intensive, and it's not obvious that JavaScript is the first language you would choose for this. So might the future of web deployments of this be more of a WebAssembly thing?
Possibly, or like a WebGL pipeline. Again, I'm not super into the rendering side, but yeah, it's going to depend. Again, like if I was visiting an A-frame experience, I would navigate there in my web browser in here. You know what I'm saying? So it kind of depends on what your end hardware is capable of pushing out to. Yeah, does that answer your question at all? I don't know if that was adequate.
I mean, conceptually, like your WebAssembly can be embedded in a page like JavaScript. Just pick your language out of that.
I gotcha. Okay. Yeah, I'm not familiar with that, I guess. So, interesting.
Well, A-frame runs on Three.js, but it runs on WebVR.
Mm-hmm.
So you get the video acceleration on it.
I mean, I think the improvement JavaScript's fast. Just the capability of the processor running it and how fast the browsers
Well,
are.
no, the rendering that happens in JavaScript happens in WebGL.
Right, which is the core process of the browser itself, right?
Yeah, and it's GPU accelerated.
Right.
Mm-hmm.
So it depends on how fast the JavaScript can execute to get the browser. The browser's most likely to bottom with that one, I would think.
It's just a library.
Yeah, exactly. So if you have a GPU, a machine with a powerful GPU, you're going to be able to do great with WebVR, especially as the spec advances.
Can you rent those?
I'm not sure. Like I said, this one came out yesterday, so probably not. But yeah, it's still in a weird place, the hardware market. If you're going to do something that's not a mobile untethered, again, you have to have that PC with a powerful GPU usually. So yeah.
Have you gone through the development experience with the Quest yet?
No, I did the Go. I put out a story up app for the Go, which was this thing's kind of predecessor. The major difference being that was like for stationary experiences. There was no full scale movement, room scale movement on that. It's an intense development process because for every change you want to test, I mean, it's not easy to write a test suite to simulate a 3D world and what happens when your code executes in that world. So it's more manual testing than not, I think is really industry standard practice at this point still. So if you make a change to your code or there's a bug in your code and you want to make a change to try to fix it, it's like, okay, save, export to Android Studio, or actually Unity just builds APKs now. So build APK, takes 30 seconds, 45 seconds, install via ADB, wireless or tethered, and that's another 20 seconds. Then you got to get in the game, put it on. So the mobile development process is much more intensive and kind of rigorous than if you have that PC tethered headset. Again, you can just hop in, hit play, you're right in there within the editor. It's super cool, and much faster iterations in that model. Does anybody here have experience VR? Anybody tried out anything?
Only as a player. But,
Okay, sure.
what are the room scale, max dimensions that you can do? So I know if I have to buy
Yeah. Yeah. It's different per sensor type. So I think even there's like a new Vive sensor, which is like 2.0 trackers, that you can have like 8 of them. And so you can set up like factory scale experiences where you're tracking every, hundreds of yards potentially. With this, which is the first 6 degrees of freedom, if that's confusing. The first 6 helmet, the size is unlimited. We could go outside and play on a huge field essentially, and yeah, it's really neat. And that's a pretty big difference, yeah. Before you kind of had to have the setup in your home, you had to have space set aside. Yeah, where now I could go out, we'd go in the parking lot and just kind of kick this thing around.
Do the sensors run off infrared on this system too, or is it different?
It is infrared, yeah, as far as I know. I would be, oh man, if Facebook had 3 RGB cameras in my house for the last 3 years, that would not be good. Yeah, that's a down. I'll talk about that, I guess. Like, this is Facebook. Facebook owns Oculus. Kind of sucks. So I don't trust them with privacy, and the privacy policy is not super clear. I mean, they make public statements about how they're committed to it, but yeah, I don't trust them. So I wish there were more platforms available that could have this sort of capability. It just doesn't right now.
Anybody else got any questions?
Do they train you on the job to use these? Like if you're training to work for somebody, do they actually train you to use this?
I got into it at work. I worked in a creative, like kind of an events agency, and they had like big corporate clients that they would host events for. These clients were always looking for the big, splashy thing they could have. So the company charged me to kind of get into it and investigate like where could the company, how could we navigate that space when it's so early. Ended up putting out a lot of cool proposals. So I partly learned on the job. I mean, I guess it's just, does your company, have an interest or a use case for this tech at this point? Yeah.
All right, James, thank you.
Yeah. How are you? What's up?
Thank you guys for coming